Resistors do what they sound like they're going to do. They provide resistance to the flow of current in a circuit. This is a battery, and we saw this when we played with the flashlights. The resistance was in the form of a light bulb. And later on, we took a pencil and drew a line, and then I took a multimeter and put the probes on the line and measured the resistance. How much resistance we got turned out depended on how far out I put the probes. If I move the probe further out this way, we got more resistance. Resistance increases as the distance that the charges have to flow through increases. So it's just that simple. If we have one resistor and then another resistor, I call that R1, I call that R2. R total is equal to R1 plus R2. If we added a third resistor, you'd say plus R3, and so on. It just keeps going like that. Now, this is what we call series. The resistors are in series. Well, in that same experiment with the pencil line on the paper, if I colored it in wider and darker, I added more material to the paper, but when I put the probe here and the probe here and measured the resistance actually got lower. How did I get lower resistance? Well, it's kind of like the analogy we used was cars in a traffic jam. If this was a highway and there was traffic and they were bumper to bumper, well, what if that was because there was a blocked lane, and now I added another lane for the traffic to flow on? Then the more cars can go by. And so that's what happens when you give the charges more room to move around. There's more paths for them to go on, and the resistance is lower. Well, that would be like doing this with our resistors. R1, R2. Can you see how a charge going this way could go this way? Another charge could go that way. It makes it easier for them to get through. There's more paths. That's called parallel. And the formula to do this is 1 over R total equals 1 over R1 plus 1 over R2. And what if I had a third resistor? It'd be plus 1 over R3, and so on. So here we have example 1. Let's say we had a 5 ohm resistor and a 3 ohm resistor. What would be what we would call the equivalent resistance? In other words, if this was in a circuit, could we replace these two with a single resistor? Now, I use the idea of R total. Sometimes they call it R equivalent. And it's the same thing. The equivalent resistance would simply be 8 ohms. We just add them up. Example 2, now we've put these two resistors in parallel. How would you figure out the single resistor that could replace these two in a circuit? It's like saying the total resistance or R equivalent. It would be equal to 1 over R1 plus 1 over R2. So 1 over R equivalent is equal to 1 over 5 ohms plus 1 over 3 ohms. Every year I have kids say, well, can't we just flip this? Algebra doesn't work that way. You could do it in decimal format on your calculator, or we could find the common denominator and write 3 over 15 plus 5 over 15. And that would be equal to 8 over 15. But you have to remember, that's 1 over R equivalent. A lot of people say, oh, we're just going to put that down as the answer. Now we get to flip it over, okay? So what is the R equivalent? Be 15 over 8 ohms. Or 1.875 ohms. Now that's kind of interesting. You might notice that this number is actually lower than the lowest of these two resistors. Like I said, if you had all the charges trying to get to that 3 ohm resistor, and then we added a 5 ohm resistor, that's going to allow some of the current to go this way, making it easier. This is a compound system of resistors. We have a single resistor, then it splits off into these two parallel to each other. So really what we have is a parallel and a series system in one. So first thing we need to do is replace these two with a single equivalent resistance. That's still 10 ohms. But when we use the formula for parallel resistors, 1 over R equivalent equals 1 over 20 ohms plus 1 over 5 ohms, you're going to get an equivalent resistance of 4 ohms. Now, what do we do to add these together? To just replace it with the 1, you have 14 ohms because it's simply R equivalent is equal to R1 plus R2. Let's take a look at example 4. Now we have a parallel, and in this side of the parallel, we have these two in series. This system could be replaced with just these two resistors. This one being 10 ohms, and this one being, because they're in series, 5 ohms. How do we replace these to get it down to something just one equivalent resistance? Now we have to use the formula for parallel resistors. And we get an R equivalent of 3.33 repeating ohms. As you can see, these things can just build up and get more and more complicated. We'll just take these and add them together and have 20 ohms. And then all these are going to be, we're going to simplify them first and make this 10 ohms, 4 ohms, and then 3 ohms. Now we can add these together as parallel. So we'll say the equivalent, 1 over the equivalent is equal to 1 over the 10 ohms, plus 1 over the 4 ohms, plus 1 over the 3 ohms. And the R equivalent is going to be 1.46 ohms. But remember, this is only for these three here. So we'll replace them with the single resistor of 1.46 ohms. Now we can put them both together and get 21.46 ohms for the equivalent resistance for the whole system. Now, sometimes you're given problems where they don't use numbers. It's just the variable. So let's say each resistor was the same, and that was R. So the equivalent resistance for just these two, well, of course, would be 2R. And how did you get that? Because you just said this is 1R plus 1R to give you the 2R. And if it was in parallel, you'd say 1 over R equivalent is equal to 1 over R plus 1 over R. And then that would be 2 over R equals the 1 over R equivalent. And now to rearrange this, you would say that the R equivalent is equal to R over 2. And to do the compound resistors, we'll first simplify this side and say this could be the equivalent of R over 2. And we're adding it to R. So what do these two add up to? You would write in series now. R equivalent is equal to R plus, you could write it like this, 1/2 R. And if you wanted a common denominator here, you could write that as 2 over 2. And then you'd end up with 3 over 2 R for R equivalent. Now imagine you were given four resistors, four separate equal resistors. How many different values of resistance could you get?